Welcome to another exciting episode of Doug's Electronic Repair Day.
Hi, afternoon YouTube. I'm back with you once again for another excursion into breadboarding. Yes, I have another little project to breadboard here that I want to try out. You may recall that I was working on my little parts thing there, harvesting parts last week. I came across some LEDs and I thought, you know, that'd be nice to have an LED in my little power supply that I'm building for the AM transmitter. And I thought, but that's a 12 volt circuit, so how in the world am I gonna figure out what values to use for the resistor? So what better way to do that than breadboarding? And before I even breadboarded, I thought, you know, it would be nice to get an idea of what I should be using in that circuit to use. So what I did was I found some sites on the internet. You all know the internet, and those sites will calculate values of various components that you need in order to have a circuit draw a certain amount of current, or use a certain resistance, or use a certain wattage, whatever the case may be. So I have a couple of sites here to go look at, and let's go ahead and go to that real quick, and then we'll come back to this. Alright, for this portion of the demonstration, we're going to use the ice cream screen recorder, and that's how I'm doing the screen recording right now. So see how well that works out, and we'll get into the calculator that we need to find the value of the resistor that we want to use. So let's go there now. Alright, we're heading there now. I have it saved in a bookmark for me, so we're at the calculator now. So what we're going to want to do here is move that up just a hair, and now we will figure out what we need to put in this calculator to get it to work right. A couple things we know for certain is the fact that the source voltage for the project will be 12 volts, and the voltage drop of the LED for a red LED is supposed to be around 2 volts. So that means our resistor has to drop 10 volts, and we'll plug that into our formula here. Now the next thing we need to know is what kind of current is going to be flowing through this circuit. Now, from what I understand, I've done some research. The maximum current these little LEDs will be able to draw is 30 milliamps, and the maximum they draw on a normal, that would be the peak, I should say. And for the maximum they draw on a normal circuit would be 20 milliamps. We're going to shoot for 10 milliamps, which is half of that. And the reason I do that is for safety primarily. And so let's put that 10 milliamps into the calculator. First thing we're going to do is change the amperage over from amps to milliamps. Once we do that, we'll put in 10 as our figure. Now the only thing that we have left to do is hit the calculate button, and we can see right away that our value of our resistor should be 1000 ohms, and the wattage is a 1/10 of a watt, so a quarter watt will be fine, and we can close out of this calculator. For our next little demonstration, we're going to double check our work by selecting another calculator that's on the websites here. And this one is specifically used to calculate the resistor needed for any given LED circuit and voltage and input. So let's go to that one now and we'll see what we got. Alright, for this one it's going to ask for the source voltage on the top, and the next one is the voltage drop of the diode, and finally the current that we expect to draw through the diode. So let's fill those in and see what we got. Alright, we're going to put in 12 for our source voltage. That's the source voltage. And for our voltage drop, I believe that was 2. Got that in there. And our current is going to be, as I said earlier, 10 milliamps. So when we hit the button, it calculates our resistor needed, and as you can see very, very clearly, it is 1,000 ohms. So I think that pretty much means that we can safely put in 1,000 ohms in our breadboarding experiment and put our LED in there and see how everything works together. So now that we've got that all done, let's try it and see what happens. Alright, back again, and you see now what we're going to use is 1,000 ohm resistor. And I know I have one of those in that those parts that I harvested. I seen it as I was taking it out of. Those are very distinctive brown, black, orange, brown, black, red, and they're very distinctive. So I'll get one of them, and I'm going to get the LED, and I'm going to connect it up to our power supply that I made off the Variac, because that has a current meter on it, and we're going to use that. And normally I would probably use this little one I built, but it doesn't have a current meter on it, so I think the thing to do is to use that one, and we can put a camera on it and watch the current draw. Now I would optimally like to have this draw about 10 milliamps. 15 would be acceptable. So if we put this in there and it says 15, that'll be perfectly acceptable. This is just a pilot light's all it's going to be. So when we flip that switch on, this LED will light up. So without any further ado, let me show you one thing that I did. I took the power supply itself that I've been working on, and it was sitting right here in the on the bench, and I moved it. And there it sits down there in a noodle/project box. All the pieces that I'm using for it are in that box, and as soon as those 12-volt regulators come back in, I will continue on with that. And like I said, in the meantime, let's do this breadboarding. That'll be fun. We always like the breadboard thing, so let me get set up for that and we'll take it away. Alright, what we have here is our circuit, and it's all wired up like it's supposed to be. If I can find me a nice pointer here, let's just use a screwdriver. Here's our positive leads coming in. It goes to the end of this resistor. By the way, I did check the resistor. It measures 996, which is very close to 1000. Goes through the resistor, comes around here on this red wire, and back down into the diode LED, and it goes through the diode. It comes out on this side and goes to our negative lead here. So that's the complete circuit, and what we're going to do is, I've already got this set up, so let me point you over here. As you can see, there's 0.97 or 9.7 volts on the Variac. Get that out of the way a little bit. And we're going to turn the DC part on, and looky there. We have measuring 12.4. Let's turn that down just a hair. I had it right on 12.04, but the changes a little bit. Alright, 12.2, that's close enough. I have 10 milliamps, 0.01, that's 10 milliamps. And if we look at the diode, back over here, it is lit up. How about that? Now that's, like I said, that's drawing 10 milliamps through the resistor. That's not real bright, but I think it's bright enough. If we turn this up like this, you can see it's plenty bright enough for a pilot light. And like I said, that will work out just fine. So that's one easy use of breadboarding to test circuits. And like I said, let me get off this and go back to the other camera. As I said, that's this is one good method, good use for breadboarding. That's a very simple circuit, I agree, but in order to test it, to find out what kind of amperage it's drawing, things like that, you really need to try it out. It's fine to calculate things using Ohm's law, and that's certainly a way to do it, but you always want to see how they actually perform in real life, and breadboarding is the way to do that. So this has been a very short breadboarding demo, but like I said, a valuable one nonetheless. And like I said, it's I think it's exactly what we needed. So we know now exactly what to use for our circuit on our power supply, and that will work out rather nicely, I do believe. And the only thing I didn't really cover too much on this was the fact that the anode and the cathode of the LED has to be correct for it to light up. Now the only problem, if it's backwards, it won't light. No harm will be done as long as there's not excessive voltage applied to it. But for our intents and purposes here, you know, just all you do is reverse it and everything's fine. So like I said, I will put those two components in our little bag of parts there that go with the power supply, and as soon as those the part came in, the 12 volt regulator comes in, we will get back to that. So I thought this would be an interesting aside to bridge the gap between the two, and I may actually go ahead and work on the high voltage power supply that I'm going to be running off the Variac also. I've had some suggestions on what to do to differentiate the difference between the low voltage and the high voltage. I'm going to obviously put a low voltage supply on one and put a high voltage supply on the other. But basically, I'm going to paint the box a different color, and I'm going to maybe add a flap as it was suggested by Bunny, and may do that too. But whatever I do, I'm hoping it will be enough to keep me on my toes enough to where I won't try to put in 400 volts into my little projects like this. I think 400 volts would pretty much zap that little LED pretty quick. So you guys have a great day. I really appreciate you watching, and I'm going to come up with a better intro for this series. I just haven't got around to it. I had to take Lexi to work today, and she works kind of a short day today. It's only 6 hours, I think. So once I pick her up, I can get back to work or whatever I'm doing. But really not doing much of anything. But I just wanted to make this little demo on this breadboarding. I thought that would be ideal for a breadboarding episode, and you know, something that's very useful that we need. So you guys have a great day. Thanks so much for watching. See ya.